Game show. I'm going to read this. I hope you've all read this. Take some time to read it, try it, and then go on to the solution. A new game show on TV has 100 boxes numbered 1, 2, 3, 4, 5, all the way till 100 in a row. So you have 1, 2, 3, all the way till 100. Each containing a mystery prize. The prizes are items of type A, B, C, D, E, F, and so on, in decreasing order of value. The most expensive item is type A. A is the best, which is a diamond ring. Fantastic. And there's exactly one of these. So A is one of these. You told the number of items at least doubles as you move to the next type. So number of Bs should be greater than or equal to 2 times number of A's. Number of C's be greater than or equal to 2 times number of B's. For example, there will be at least as many items of type B as of type A, at least twice as many of type C as of type B, and so on. There is no particular order in which the prices are placed in the boxes. What does that mean? This could have a C, a D, E, and then an A, and then C again, and so on. It's not like A is placed in the first box, and then B's, and then C's. None of that. Right? Wonderful. So far, so good. I've got a hang of this. 100 boxes, different types. Let's go on. That's it. There's nothing more. We just have to go to these questions. What is the minimum number of types of different prices? There is one of A. So the minimum number cannot be 1. There be some number of B, C, D. Minimum possible number of different types of prices. There are 100 prices to be given of. A should be 1. B should be greater than or equal to 2. C should be greater than or equal to 2B. What is the extreme scenario? B should be 2. And then C goes up from there. But that will be for many types of prices. For minimum, I have 1A. And then I have 99B. There's no condition that's contradicted here. This could work. The minimum possible number of different types of prices is 2. Just A and B. 1 diamond ring and 99 of B's. Whatever that is, that will work. That satisfies all the conditions given, and we are through. What is the maximum possible number of different types of prices? So we have an A, B, C, D. We want to go as far as possible. We have one of A. That means each of these has to be as low as possible. That means B should be 2. B is greater than or equal to 2, but make it 2. C should be greater than or equal to 4, make it 4. D should be 8. E should be 16. F should be 32. And so on. So forth and so on. 1, 2, 3, 4, 5, 6. G, but we have only 100 to give away. Remember, these 2 add up to 3, a lot of room. These 3 add up to 7. These 4 add up to 15. These 5 add up to 31. Up till F we add, we'll get 63. So there's no room for a G. And so there's no room for a G because G has to be at least 64. That's not possible. But if we had only 6 till F, we could have 1, 2, 4, 8, 16. These add up to 31 and 69. A, B, C, D, E, F. This is a possibility. 1, 2, 4, 8, 69 will add up to 100. All conditions are satisfied. This is at least twice this, at least twice, at least twice, at least twice, way more than twice. And so with 6 it is possible. There is simply no room for the 7th one. Maximum possible number of different types is 6. Go to the next one. Which of the following is not possible? There are exactly 30 items of type B. A is 1. B 30. C should be greater than or equal to 60. Twice of this. 1 plus 30 is 31. C could be 69, adding up to 100. This is possible. I'm going to create scenarios where each of these is possible. And then we'll just say, we'll look at the one thing that is not possible, work from there. 75 items of type E. So A is 1, B, C, D, E. E is 75. So these 4 should add up to 25. And let's put this as 2. This is 5. 1 plus 2 plus 5 is 8. 8 plus 17 is 25. Twice, more than twice, more than twice, more than twice. This again is possible. Look at C, A, B, C, D. A is 1, B is 60. These two add up to 61. These two should add up to 39. Totally there are 100. And so this should be at least twice as much as this. So C is less than 30. C is greater than or equal to 2B. Wonderful. So I'm going to put C as less than 30, but the total is 39. C cannot come to be 20, then the B will only be 19. So I'm going to put it very close to 30. Maybe put 28 in here, 11 in here. 1 plus 11, 12, 40, 60. More than twice, more than twice, more than twice. This works. Right, C should be less than or equal to 30 technically. Doesn't matter if you found something less than 30. This is also possible. This is telling us that this should not be possible. Let's check this out. A, B, C. This is 45. This is 1. These two add up to 46. So 54 remaining. That cannot be here. So there should be a D also. But if there were a D, D should be greater than or equal to 90. That's not possible. So this one is impossible. 90 plus 45 is 135. We need a total of only 100. So C cannot be 45. E can be 75, D can be 60, B can be 30. But C being 45 is impossible. And wonderful question. You ask for the type of item in box 45. Instead of being given a direct answer, you're told that there are 31 items of the same type as box 45 in boxes 1 to 44. 1, 2, 3 till 44. The 31 of your type. Then there is box 45. And 43 items of the same type as box 45 in boxes 46 to 50. Close. We have a total of 43 items here. So let's say this is type X. Type X, there are 31 plus 43 plus 1, because this is also of type X. So type X has 1 plus 3, 4 plus 1, 5, 3 plus 4, 7. 75 items of the same type we have. That much we know. We know that A is 1. We know that this is not B. Maybe this is C. Maybe it is D, etc., etc., etc. What are the maximum number of different types of items? And we've already done something very similar to this a couple of questions ago. So this can be 75. B cannot be 75. C can be 75. That much we know. I want to think about, we know the maximum total is 6. And that will happen when you have 1, 2, 4, 8, 16. Right? I want to think about 1 and 75. We want remaining is only 24. We want to fill the gaps with these 4 gaps with 24 added up. 2, 4, 8, 16 are the smallest numbers we can put in. That is not possible. So 6 is ruled out. Now let's look at with 5. So A, B, C, D, E. E is 75. So B, C, D should add up to 24. Put a 2 here. A 4 here. 2 plus 4, 6. We want 24. Put an 18 here. So 1, 2, 4, 18, 75. The total is 100. All conditions are satisfied. With 6 numbers thrown in, with 6 different types thrown in, it is not possible. With 5, we've got one possibility. 5 is the correct answer. Street intersection. The figure below shows the street map for a certain region with the street intersections marked A through L. So we have, let's look at this. A, B, C, D, E, F, G, H, I, J, K, L. So there are 12 intersections here. A person standing at an intersection can see along straight lines to other intersections that are in her line of sight and all other people standing at these intersections. Remember, from if you're standing at E, you can see I, A, F, G, H. If you're standing at B, we should be able to see F, J, A, C, D, and G, straight lines. For example, a person standing at intersection G can see all the people standing at B, C, E, F, H and K. In particular, the person standing at intersection G can see the person standing at intersection E irrespective of whether there is a person standing at F. So from here, I can see this even if there is somebody standing here. Wonderful. So it's in a straight line, I can see. Maybe I'll shift a little bit and see, but I can see. Whoever is standing on that straight line, on that road, I can see, even if there is a person bang in between. Wonderful. 6 people, U, V, W, X, Y, Z, are standing at different intersections. No 2 people are standing at the same intersection. The following additional facts are known. X, U, and Z are standing at 3 corners of a triangle formed by the 3 street segments. Triangle. Only triangles formed are here and here. So straight away, this is referring to either BCG or BFG. These 3, X, U, Z, are at BCG or BFG. X can see only U and Z. X can see U and Z. That we know because they're standing at 3 corners of a triangle. Can see only U and Z. Very important. Cannot see anyone else. Y can see only U and W. Okay, good. U sees V standing in the next intersection behind Z. So there's a U, V, Z straight line. Either like this or like this. Vertical or horizontal. It could be left to right. It could be top to bottom, right to left. Doesn't matter. U, V, Z is a straight line. W cannot see V or Z. And W cannot see V or Z. I'm not going to work with this because this is a negative constraint. Who he can see. No one among the 6 is standing at intersection D. So D we can rule out. And so how are we going to work with this? I like constraint 1 because it gives 3 in 3 vertices. There are 2 possibilities, but there's still only 2. Then X and U are already in, and Z is also in, and we incorporate V also, the straight line idea. So using constraint 1 and 4, we can create possible outlines for 4 out of the 6. Then the other 3 will use the other constraints, 2, 3, and 5. 6 is obvious to incorporate. And so think about this. This marks are a diagram. I'm going to think about X, U, Z at BFG or BCG. Remember, X, U, Z or X, U, Z in some order. And I'm going to think about U and Z because there is going to be a V behind it. And so you could have U, Z and V. But remember, there's nobody at D. Right away that is ruled out. So we could have a U, Z, V. If you're thinking about BCG or U, Z, V, but U and Z cannot be at B and G. And now let's go to BFG. You could have U, Z, V. You could have U, Z, V or U, Z, V. The U, Z, V can be along this axis for the triangle BCG. For BFG, it can be along this axis. It can be along this axis and this axis for BFG. Using X, U, Z, V, we are somehow managing 5 different possibilities. And I'm going to go step by step and incorporate those 5 possibilities. Let's break it down. The triangle could be the BCG triangle or the BFG triangle. And so nobody is standing at D. That's the easy part. Between this and this, we could draw some possibilities with BCG triangle, some with BFG triangle. I'm going to pick one of the 2 triangles, draw all possibilities, then go to the other triangle methodically. And so let's say we pick up BFG. And so we could have UZV like this, UZV like this, and UZV like this. UZV, UZV, and UZV. We cannot have UZ the other way around. There's no room for V this side. And so left to right, bottom to top, top to bottom. Right? So three possibilities here using the triangle BFG as X you said. Right? Brilliant. Now we know that X can see only U and Z. That means if you look at this possibility, X is here, there's nobody here, nobody here, nobody here, nobody here. X can see beyond Z also, remember. Now here, there's nobody here, nobody here, nobody here. X were here, nobody here, nobody here, nobody here. Brilliant. So we incorporate that constraint also and we get to this point. X can see only U and Z. What other constraint do we have? We see that Y can see only U and W. W cannot see V or Z. Y can see only U and W. There's U here. Who can see U? That means U can see W. This is U. This can be W. Y should be able to see U and W. So U should be able to see Y and W. That's not possible. From here, there's only one option available. Is ruled out. Wherever we put Y here, Y cannot see U. If Y can see U, that means U should be able to see Y. And so U is seen by X, U, Z, Y, all of them. Right? Y can see only U and W. W cannot see V or Z. Y can see only U and W. Okay, got it wrong. Y can see U. U need not be able to see W. So this could be Y. And Y can see only U and W. That means this should be W. This is the only other place Y can see. But if you put W here, then W can see V. That's not possible. But W should not be able to see V or Z. So if we put Y here, only place for W is here, then W will end up seeing V. That's not possible. Let's go to the next one. Y can see only U and W. So Y can see only U and W. So from U, there are two places that can be seen. If Y were here, then Y can see Z and V also. That's not possible. If Y were here, Y can be here. Y should be able to see U and W. So W should be either here or here. Now W, if it were here, W will be able to see V. W cannot see V and Z. W should be here. But this is a possibility. ZV, XU, UZV like this, X like this, Y here, W here. Y can see only U and W. UZV on a straight line. X can see only Z and U. W cannot see V or Z. So this works. We have a winner. Next possibility. In this sequence, let's see. Y can see only U and W. From U, this side, nothing is available here. If Y were here, then Y would be able to see Z and V also. That's not possible. So this possibility is also ruled out. So only one possibility exists. With X at BFG, these two are ruled out. Only this exists. Now let's put XUZ to be at BCG. Remember? BCG. You can have UZV like this. You cannot have UZV downstairs because nobody is here. We could have UZV along this straight line left to right. We cannot have right to left because we cannot accommodate V this side. So now we have only two possibilities. Brilliant. So we know that again X cannot see anyone other than U and Z. So let's use that. So if X is here, U and Z can see nobody here, nobody here, nobody here, nobody here. And we still need to accommodate Y and W, remember? And if X were here, nobody here, nobody here, nobody here. We still need to accommodate Y and W. Now, let's go to this constraint. Y can see only U and W. From U, Y should be able to see U. There's no possibility here. If U were here, There's no available slot here, no available slot here, nothing else is opened up. So this is not possible. U here, nothing opened up here, nothing opened up here. Again, this is not possible. Both of these are not possible. That means we have just this one glorious possibility, XZU at that BFG triangle, and then Y and W here. So XZU, UZB in a straight line like this, Y and W like this. Now let's jump to the questions. The question should become very simple. Who's standing at intersection A? Intersection A, there's no one. Who can we see? V is here. Who can we see? We can see Z and U. We cannot see X. We cannot see Y. We cannot see W. U and Z only done. What is the minimum number of street segments that X must cross to reach Y? X is here, Y is here. Minimum number 1, 2. It doesn't have to go like this 3 steps. 2 steps will do. 2 is the correct answer. Once you've got the grid and there's only one grid in this answer, then these questions become far simpler. Should a new person stand at intersection D, who among the 6 would she see? Intersection D, the new person. Who would she see? She would definitely see X. She would see W. She cannot see U, Z, V or Y. She will see X and W. W and X only. That is the right answer.